Okay, hello. Hello. Hello! It's a me. Was a me-o. Welcome to part 34, amazingly. Um, oh, hey Joel, welcome. You're in right at the beginning. I'm very impressed. Thank you for coming. Yeah, this is part 34 of me writing a WebAssembly interpreter in Ruby. I'm doing that to have fun, primarily. I'm doing it to demystify WebAssembly for myself, maybe for you, and just generally to sort of share how I work on stuff. Reminders for me, yeah, the point of this is to have fun, more than to make a functional WebAssembly implementation. I want to write code that's correct. I want to write code that's clear. I want to write pure Ruby only. I think I'm sufficiently far through this that does feel achievable now. And I'm trying to write code with no third-party dependencies as well. So before I get stuck in, as always, just a brief retro. So last time I got 22 more test scripts working. I mean, I've clearly got some kind of off by one error somewhere because these numbers aren't adding up. But I definitely got 22 more test scripts passing last time. And all of those, except the last one, tokens.wast, came for free because it turns out they were already passing and I just didn't know about that. So thank you very much to Chris Zeta for pointing out that I should check to see whether I was in that situation. It turns out that, yeah, most of the remaining tests were now passing. So this is obviously very exciting. You don't need me to tell you how exciting this is, because it feels like being able to run the those assert return assertions, the sort of happy path assertions, in 100% of the core test scripts is finally within reach in a way that it hasn't been until now, basically. So, basically, I really want to take a shot at this tonight and see whether I can just get it done. I've only got 8 scripts left to go. That seems doable in one session, so I'm just gonna crack on with that, basically. Now, obviously, when I get to that point, it won't be the end of the project by any means, because I've got many other kinds of like failure assertions to worry about, like, when you call this function, it should raise an exception, or, this bit of source code contains a syntax error and things like that. And I haven't thought about how assertion handling should work. I haven't implemented those assertions yet. But it will still be a significant milestone when I get 100% of these test scripts passing just for the assert return assertions, because it would mean that all of the happy path functionality is working and I have all of the like main language features in place and the semantics of them all sort of working correctly, because each of these test scripts is sort of cutting across one feature of the language and sort of exercising it in quite a lot of detail. And so if I can, well, I mean, obviously a couple of those scripts I'm not actually running, they don't contain a single assertion that I'm running, but even just like being able to parse all of them and execute all of those assert return statements in them means that, I've basically implemented WebAssembly, which is the point. The point's to have fun, but you know what I mean. This is ostensibly what I'm making is something that implements WebAssembly. So yeah, I'm sort of excited about that. So happily, I did also get a preprocessor wired up and handling the abbreviations for imports and exports, which turned out to be a little bit involved, but mainly because it flushed out a bunch of stuff that was still wonky, not implemented correctly, implemented sort of ad hoc rather than in a consistent way. But I got it done last time. So overall, that feels like a big win to have introduced that preprocessor, and I'm really happy with how much junk I got to delete from the AST parser and the interpreter as a result of writing it. So now that the preprocessor exists, I do gradually want to move more of the special cases out of the AST parser and the interpreter and into the preprocessor. So like, you know, where some bits of syntax have a default when they're missing, you know, I'd like it if the preprocessor could handle that rather than either the interpreter or the parser having to, you know, having to know what the default is in that case. And the more I can do that in the preprocessor, the more I'm able to just sort of regularize what the rest of the system has to be able to cope with. I mean, in particular, I would really like to move instruction unfolding into the preprocessor, but I think that's going to be a bigger job than what I did last time because it involves understanding how many sort of immediate arguments, how many static operands each instruction has, and that knowledge currently lives only in the AST parser. So I would need to find a way to somehow share that knowledge between the preprocessor, which would do the unfolding, and the parser, which would then consume the unfolded instructions. But to do either of those jobs, you need to know, is this an instruction that's just a single atom, or is it a single atom with an argument, or with two arguments, or with a variable number of arguments, or whatever. So I'm going to park that for the moment, but I'm going to bear it in mind as a sort of a medium-term goal once all of the excitement has died down of whenever I finally get 100% of these tests passing. But that being said, if I spot any opportunities to move annoying stuff into the preprocessor in order to make the parser and the interpreter simpler, I won't hesitate to do that. That's the whole point of having that. The whole point of having that preprocessor is to have a place to move that complexity to, so that it's just centralized in one place and not sort of smeared all over the rest of the system. So I think that's all I wanted to say retro-wise. So I might as well get into it. So I'm just going to let these tests run to make sure that nothing bad has happened. Let's check that nothing bad has happened on the WebAssembly spec front. No, it looks like, again, none of the executable tests has changed. So I don't have to worry about falling behind. What is, you know, the upstream definition of WebAssembly semantics. So yeah, so I'm just gonna get cracking straight away and look at these eight remaining tests. Now, imports was kind of interesting. Okay, good. The test's still passing. Imports dot last. Oh, that's interesting. Yeah, I mean, I'll just look at these in order and see if I can get all of them working. I think these three are going to be easy because these are just features that I haven't implemented yet. The rest of them, by which I mean, they're just instructions that the interpreter doesn't have implementations of yet. And I think I can just make implementations of those things without too much drama. The rest of these might potentially be more esoteric. I mean, I don't even know what skip stack guard page is supposed to do. Imports. Let me just have a look. I just want to check. So this is where I finished last time. Not last time, before the previous session. I'm pretty sure that at that point, because I did look at this, I was like, oh, maybe imports is still passing. And then I shied away from it and I said, oh, no, I want to do the desugaring first with the preprocessor and then come back to this. So I did do that. So, well, I did the desugaring. I didn't come back to it, so I'm coming back to it now. So yeah, I think my hesitation was that this was having some kind of problem about, well, I mean, it looks like it was having a problem looking at one of the identifiers. So actually, this might have been, I did have to fix a load of problems to do with identifiers not being put into the initial identifier context last time. So it might be that, well, in fact, this is a different error than I'm seeing now. So whatever was causing this error has been solved now, either through those changes to the initial environment, the initial identifier context, or through the expansion of those abbreviations and stuff. But I don't know exactly. It looks like it was a table index, probably. I can't remember whether I think I did make some changes to tables in the identifier index, in the identifier context. But anyway, So that error has definitely changed since last time. And in fact, this looks much more tractable because this is just complaining that it doesn't know how to parse this assertion, assert unlinkable. I don't know what that is. But I think I can just add it as an unsupported assertion. Assert. What was it? I'm sorry, that's embarrassing. Oh, goodness sake. It's like literally just, I was talking out loud and it just fell out of my brain. Okay, assert unlinkable. Making the unlinkable possible. So, okay. Some other error here. Oh, look, I know what this is. But this looks like something that I can, this is an easy thing. Add assert unlinkable to unsupported assertions. Let's say AST parsers, unsupported assertions. Okay. I'm going to make Etienne sad again for the 1000th time by explaining why I'm doing this. And, oh, goodness sake. Every time I try to scroll when I've been typing stuff, it just inserts junk. If I was clever, I would know what to do about that, but I don't. So here I'll just say this is needed by imports.wast. Well, let's say used in imports.wast. So now this is straightforwardly saying I can't find print I64. This must be, it must be looking in spec test. I think the spec test module. Let's have a look. So again, this isn't really documented anywhere, at least not comprehensively. But there is a little bit in this README here. It doesn't tell you what the values of these need to be. It's 666 incidentally. But yeah, you can see I should have all of these functions defined. And I believe that if we print, see, I've got print and print I32. So it's not a surprise that it can't find print I64. So let's just do that. Oh, print F32. Okay, all right. What order are these in? I32, I64. I mean, I imagine it's going to need F64 as well. It looks like it's... Yeah, there we go. F64. Okay, is that it? Ah, print I32, F32. Print F64, F64. Okay, so is that all of them? Print I32, I64, F32, F64, I32, F32, F64, F64. Yes. So hopefully, unhandled exception. Yeah, I mean, this error reporting leaves a lot to be desired, doesn't it? Unhandled exception, line 140. Oh, the stack's not empty after function invocation. Oh, okay, I know where that is. It's because these take 2 arguments. So what I'm doing inside the body of the function here is just throw, this function is a no-op, but it has to consume its argument. And in this case, we need to consume 2 arguments because the arity of both of those functions is 2. Ooh, okay. More of this. Global F32. And also global F64. So let's see, F32, F64. Now what's the right value? Because here I've just given it literally 666, which is fine for these first 2, but these are supposed to be IEEE 754 floats. What does the... Let's just look at global F32. Oh, okay. Well, this isn't what I was expecting to see. I was expecting, I mean, this is all completely arbitrary. Like this, I don't really know how to interpret this stuff here, but this does look to me as though this is probably the underlying representation. So the value of this float is not supposed to be 666.0. It's supposed to be whatever float this pattern of bits represented as decimal 666 is as a 32-bit or a 64-bit float. So actually, I think probably what I've done here is the same, right? I've just said we're just going to initialize it to be that. Okay, well, this looks like a different... This memory to inf is not part of this spec test module, so let's add this, add missing globals, and I mean, is that all of the... Is that all of them? So those 4 globals, table, memory, and then all of these print functions. Yeah, add missing globals and functions to spec test module. These are used by imports.wast. We have all of the, just link to this, spec test module exports now. Okay, cool. So I'd rather be doing this in another tab, really. Imports. Okay, so this is saying key not found memory to inf. So this is almost certainly going to be... Oh, it's inside build memory. I was going to say this is going to be about looking something up in... Oh, there's like an export missing, I think. So here's, yeah, okay. So it is. So when we're trying to build the memory, there's a memory is being imported under the name memory to inf, and that export is not being found. So let's take a look. Export memory to inf. Okay, and it gets imported here. So I don't know if I ever implemented this. I could build exports. Ah, Oh, I remember I did this last time and then I backed out of it because I didn't have a failing test. Well, now I've got one. So this is when we're processing the exports, if the kind of thing that is being exported is a memory, then we want to do result, whatever name it's being exported under equals, or really this should be memories.slice index, but we don't have an array of memories. There is only one. So I'm going to have to pass it in here, basically ignore the index. Well, hold on. I can do this. I just have to pass in, I just have to fake that array up, right? Like I should, you know, if I can make it look like this, if I can get this working, then I think this is an easy refactor to clean up the duplication here. In fact, looking at this now, yeah, there are several opportunities for refactoring here, basically. So when I call this, I have to say memories, and then I'll just pass in, I'll just make an array that contains the memory which was built up here. There's a bit of, there's a bit of an impedance mismatch here, which is that WebAssembly treats treats memories as though you're allowed to have more than one of them, which is why we get an index and look it up and all of that stuff. But as I talked about last time, I think you're only allowed one. So this doesn't, this could be memories equals build memories. But ultimately, I think it's only ever going to be a one element array. So I need to make a decision here about whether I'm going to leave this as build a singular memory or if this should become memories here. But for now, I'll leave it alone because it was just for regularizing the implementation of build exports that I've introduced that array there. But let's see what happens. Hey, they're all passing. Okay, cool. So, well, I'll run all of the tests while I'm thinking about this. So what did I say last time? Build exports. Is this lib was minute interpreter.rb. Ignore inline exports. Oh yeah, it was this one. Add explicitly exported tables to exports during module instantiation. So I should probably do something similar to that, just so I don't have to think of another commit message. Add explicitly exported memories to exports during module instantiation. Yeah, all passing. Again, I'll say this is needed by imports.last. Although WebAssembly currently supports only one memory, I've decided to pass an array of memories into build exports. Oh, the build exports method to make it more regular, since it also gets an array of functions, or since it also gets arrays of functions, globals, and tables. Well, and exports? No, that's something else. No, I remember I'm actually not sure about this. I'm not sure that it only supports one memory. I know that you're only allowed to make a an active data segment that initializes the 0th memory. But actually, I remember now that I'm not 100% confident about what I'm saying here. So I'm going to say, although we, our modules currently support only one memory. Well, maybe it's just have only one memory. Oh God, this is a pain, isn't it? Okay, let's just not think about how bad I am at Vim. Okay, and now I can add, I mean, arguably I should have made it pending, but I feel like I'm racing towards the finishing line here. So imports. Add imports.wast to parsing tests. And let's just run it to check that I haven't screwed that up in some invisible way. Okay. Well, that was quite easy. Inline module. Func, no matching pattern error. Okay, so what's inline module? Oh. Okay, so there is no top level module here. So what does the... So, I mean, it's obvious what's going on here, which is that there's sort of an implicit module if you don't explicitly provide one. But how is that? So if this is characterized in the language specification as an abbreviation, then I would be tempted to, rather than teaching the parser anything, I would be tempted to teach the preprocessor about that abbreviation so that this actually becomes syntactic sugar for a module containing a function definition, and then the AST parser doesn't need to know about this abbreviation. But let's just see. I assume it's under modules. Abbreviations. Here we go. In a source file, the top level module surrounding the module body may be omitted. So what this is saying is, if there are a sequence of module fields being these things, then that's treated as being implicitly surrounded by a module. So I'm just thinking about how we want to deal with that. Hi, Chris. Welcome to the stream. Chris says, great, you're already getting more use out of the preprocessor. I know, right? It's already paying dividends. Well, I mean, I haven't actually done anything yet, but it's nice to know that I can do it. I'm just, so let me try and articulate what I'm thinking. I'm thinking about, in general, how do we know where the end of this abbreviation is? And is the answer that if you were gonna omit the top level module syntax, then that means that everything in your file is part of that module. I'm just thinking about test scripts really, where and I mean, it's not very helpful that this doesn't have an example, but maybe you can't have an example. I was thinking if I wanted to have an assertion after this, is that legitimate? And of course, this doesn't say anything about that because assertions aren't actually part of WebAssembly syntax. They're part of they are part of this test script syntax. So I'm just going to look at this kind of COD grammar here to help me to understand what is what the right thing to do is here. I mean, I guess this tells you what the right thing to do is that the thing that's being abbreviated is a series of, well, it's got an asterisk there, but let's say if you find one or more module fields, then you should wrap a module definition around them. So here, this is just inheriting the definition of module from WebAssembly syntax. This doesn't say anything about that. You know, this is saying that a module, oh, hold on. So these are alternatives, aren't they? Hold on, what's going on here? I don't know what this means. Oh, here, productions marked with respective comments are abbreviation forms for equivalent expansions. Okay, okay. All right. Well, I've never paid attention to this before. Oh, is this? So I think this is talking about this, right? Like, I mean, I have seen this before, saying that, oh, well, this is an abbreviation for this. But here, this is saying, okay, so this is actually answering my question. So there is a formal answer, which is that in a test script, which is specifically what we're executing here, it's a series of multiple or 0 or more commands. Each command can be a module definition or this register thing or an action or an assertion. So I think actually, to be completely correct, I do need to be able to support a form of module here that is specifically this abbreviation. So I think what I'm trying to say is, this is saying that it is legitimate to have a module that doesn't have the brackets around it, that just consists of some type definitions, some function definitions, some imports and exports and tables and blah, blah, blah. And then to go straight into an assertion, for example. So, I mean, this doesn't seem to be particularly germane because this test doesn't exercise it, which is a little bit annoying, but I'm going to try to implement the thing that I think we need. And in fact, why don't I do that in a unit test? So preprocessor test. So I'm going to say input equals, well, I'll start with this basic thing. Expected equals to do. I mean, I realized that this unit test, all of the unit tests could do with some cleaning up, but I'm not really that bothered at the moment. So this is saying that the input, so normally we'd expect to see something like this, right? Like that's the expected output, is that we see at the top level module, and inside that, unlike this one, it's going to be well, this is just func memory I decided to use these, fair enough. Func memory 0 export F, and then the actual input is going to be just this without the top level. So this is the simple, well, this is the exact case that we're being presented with, which is to say I want to wrap it up like that. But I suppose what I'm saying is that I also, because the slightly wonky syntax that we were looking at, that slightly wonky grammar we were looking at there, which by the way isn't trying to be, this is like for informational purposes only. Well, at least this grammar here, it says at the top, it says something like, you know, read the actual spec if you want to see what the grammar is. Yeah, shown for convenience, the definitive source is the specification. But the point is, I want to be able to follow this with a separate command and have it be able to spot that it's a separate command and not part of that module. So let's say that I do want to have assert return here. Is that the best I can do? So let's say assert return. Maybe it can just be an invoke. Invoke name. Oh, it can just be invoke string, can't it? Let's just look at an example of this. Yeah, so it can just be, you know, like invoke test, for example. Well, maybe this can be invoke f, given that this thing is actually exporting a function f. Doesn't do anything, but that's fine. So that's what I want the unit test to look like, is to say, like, this needs to be able to identify, because of course each of these is a separate field. This is an empty function definition. This is a memory definition. And then this is also an empty function definition, but it's being exported. And then this thing is not part of the module. This is something else. And so I think according to the grammar, if not according to the actual test that we're trying to get working, it should be able to find the boundary between those two things and wrap a module around the module fields without also slurping up the, you know, that action there, for example. Preprocessor test. Okay, so yeah, that first one is failing, obviously, because it doesn't work. Well, this is a bit tricky, isn't it? I was previously assuming that everything at the top level was a command. But it might not be, or rather it might be the innards of a module that we found at the top here. How do I want to deal with this? Unfortunately, this is getting back into that question of, like, do I want to be consuming the S expression as I process it? Because really what I want to do is, like, shunt things off the front of the S expression and wrap them up in a module. Process module. Oh yeah, and obviously I'm going to want to recursively process it after I've wrapped the module around it. So I'm going to need to pass it to process module. What's the best way to do this? Let's try this and say something like until this expression is empty. So something like this. So I'm just, at the moment, what I'm doing is just changing the structure of this method so that it can do what it was doing before, but do it by sort of consuming the S expression. So I think I want to say until it's empty, result dot push. So I want to push onto the end of the result. I can never remember which way around this goes. Okay, so yeah, unshift is to prepend, push is to append. Right. Something like that. Okay, yeah, so that sort of refactored this to consume. So let's say command equals s expression dot shift. Okay, so now it's chewing through that s expression one command at a time. But what I need to do is to be able to spot that we've sort of wandered into this abbreviation, that we've suddenly, rather than being about to read an explicit module, we've actually found func or type or table or whatever. So I think probably it is the case that, oh God. Yeah, I think this is okay. I think for each of these, they all begin with a distinguished. They all begin with something recognizable, right? So I think I can do something like case s expression dot first. Sorry, I'm just going to think out loud here. First dot first. You know, if it's in foo, then do something else. We're going to do this. So like this is the normal case. But I want to look for something like func. Oh no. It's an abbreviation. So this is the case that we want to be able to deal with. And I think what I'm going to have to do is well, let's just do this. Command equals My brain's getting stuck on like what the tidiest way to do this is. Anyway, I'll just make the list of things that I should be looking for. I should be looking for type or import or func or table or memory or so this is what I want to do here is slurp up each of these. So I want to like repeatedly slurp these up. Memory, global, export, start, LM or data. Right. So I'm just trying to think, do I want to... Sorry, I've got all sorts of thoughts that are competing in my head. Like, one thing I'm worried about is that this can actually be empty. Like, all of these are optional. So anywhere that you're expecting to see a module, you could just get none of this. And then, like, literally nothing is an abbreviation for an empty module. So I'm not sure. I certainly don't have a test for that case, and it doesn't seem sensible to have to think about it. But in this case, I can just say, well, what I want to do is say, if we see any of these things, then we need to slurp all of them up and deal with them. So it's almost like it's almost like inline module equals empty, while s expression dot first in blah it's like inline module dot push s expression dot shift. Like we want to, I'm trying to avoid duplicating this pattern basically. So I'm saying like the first thing that we try is to try to accumulate as much of as much of this inline module as possible. So here we take the func, we take the memory, we take the other func, and then we'd stop. And then we'd say something like, unless inline module empty, like result.push, I guess process command module inline module. I suppose because we're inside a loop here, I suppose what we can do is just, this is an attempt to read an inline module. If that attempt succeeds, then we process that inline module. Otherwise, we just process whatever the next thing is, right? So it's like, well, we failed to read an inline module. Oh, in fact, why don't I just do command equals, if inline module is empty, then it's just sexpression.shift. Otherwise, it's this. Does that make sense? So like the process of reading a command is first we sort of check for the exceptional case. And then we've got like the normal case. I think this is probably right. Let's see. Undefined method first for nil. Okay, so what's going on there? So I mean, it blasts through, you know, the normal case is working fine here. So what happens here? Undefined method first for nil. Oh, right. I have to, in this case, we've run out. Okay. Oh. Oh, interesting. Right, I didn't think of that. So actually, I think it is working right, but the problem is that it's desugaring the export. And that's actually what I should have written here. Let me just, I'll comment this one out for now and think about what we actually wanted to happen here. It's not enough to just wrap it up like this in a module. We also need to desugar all of these. So quite rightly, there should be an export here. What is it? Export F. And then is it just func? Oh, I have to give it the made up. Sorry, let's just remember how does export desugaring work? So I've got an inline export, func export i32.test. So we do get the export i32.test and then func, and then we make up an ID for it. And then in the func, we use that newly generated ID. I mean, I'm not just copying this from the output of the test because I don't want to just insert something here that's wrong. So func memory 0. So this needs to be, this is the invented ID for that function. And then for the function itself, it's just func fresh 0. I think that's right. Like we give it a function, a memory, and an exported function, and we get a module containing that function, that memory, an explicit export of that function, and then a definition of that function. Right, that's parsing. So now what am I expecting here? Something similar to this, but with invoke f at the end. And so here, just after the module definition, I'm expecting to see invoke f, because it stops slurping up these up when it encounters something other than a func or a memory or something else that it recognizes as being part of a module definition. Right, that is also parsing. Great. Okay, that's cool. And then what effect does that have on inline module? Okay, it passes. Oh yeah, there's no assertions in this thing. It's literally just a parser challenge. That's a little bit unsatisfying for something that was a little bit fiddly to get working, but can I write this more straightforwardly as a pattern match? Can I say while s expression in the first element of it is something whose first element is this, followed by whatever, and then that's followed by whatever? Does that also work? Yeah, I think maybe that's a little less gross, isn't it? Because then I don't need to, I'm not testing it for emptiness or anything like that. Okay, so what do I want to do here? I think what I should do is add that thing. So this is just the reorganization of that process script method. And then this change is, you know, a more complicated way to get the command. But we still end up just running it. So this bit doesn't change. What changes is how we get the command. There's this sort of inserting this bit about the inline module. So let's say reorganize. Let's say, what do I want to say? Consume s expression. Well, consume script one command at a time in process script. And then I'll say, this is making it possible to consume more than one element as part of a single command, which we'll need to do when we add support for inline modules in the next commit. So this is for inline module.wast. Okay. And then this is going to be so what have I said here? So this is basically like expand inline module abbreviation in preprocessor. So what's my citation for this going to be? This is the official documentation of that abbreviation. So let's say the top level module can be omitted entirely. Oh, okay. Thanks, Chris. I'll see you in a bit. And yeah, stay tuned to find out. Obviously, don't stay tuned, but yeah, please pop in later to see whether I get to the end of this. The top level module can be omitted entirely. Let's say around a sequence of module fields can be omitted entirely. So we need to add it back in as part of the preprocessor. And I think I am going to link to this as well. It's clear from the test script grammar that an inline module could be followed by an assertion or similar. So I've added a unit test to make sure that situation is supported, even though inline module.wast doesn't actually do it. I think that's okay. So now we should be able to add inline module to this because it's passing, right? Yeah. Add inline module.wast to passing tests. Great. Okay, so now just linking skip stack guard page, start, and then these table thingies. So I think I'm leaving these to last, partly because they're alphabetically last, but also because I think I know how to do them. So if anything's going to slow me down on these other things, then now's the time. Okay, so what's linking? Oh no, parse normal instruction v128.const. So I think that's one of the SIMD instructions, vector instructions. Let's just have a look at the test. Linking. Oh, come on, GitHub, just work properly. Thank you. So what is this testing? So there are some straightforward assertions here. Maybe it's just testing that register works correctly. This assert unlinkable, incompatible export type. So maybe this is mostly about checking type signatures, but there are a bunch of assert returns in here. So this could pass, and everything that I see here is stuff that we should support. Like, hopefully this would all work correctly. But unfortunately, there's this v128.const, which doesn't look like it's really anything to do with like what is actually being tested in this file. Like, this just makes a module that exports some v128 values. So let's have a look here. What is, yeah, here we go. Vector types v128. The type v128 corresponds to 128-bit vector of packed integer or floating point data. The packed data can be interpreted as signed or unsigned integers, single or double precision floating point values, or a single 128-bit type. The interpretation is determined by individual operations. So why aren't there any tests about this? Oh, there's a, okay, yeah. There's a whole SIMD. Oh God, look at this. No, no. Okay, I'm not worrying about this at the moment. But clearly 2 years ago, the SIMD proposal was merged, and that included adding support for all of these vector instructions, which I've sort of been ignoring the existence of. But curiously, it's like a little bit of leakage here. One of those instructions, I mean, it's only the const instruction, has sort of leaked into this file. Okay, so well, firstly, I'm going to have to learn to parse v128.const, and then I can see here this i64x2. Oh, okay. Let's look briefly at vector instructions. Vector memory instructions have optional offset and alignment immediates. Here we go. Vector constant instructions have a mandatory shape descriptor which determines how the following values are parsed. Ugh. Okay, well, I don't really want to get into any of this, but fortunately it seems like I can just support this i64x2. So I think this means two 64-bit integers, right? So this is effectively like a packed value, like the doc said, it was 128 bits, and one of the shapes you can have is two 64-bit integers, and I assume that these are the sort of the immediate arguments. Right, so this, yeah, to the power of 2 here actually means there are just two 64-bit ints here, because that's what this shape descriptor is saying. Whereas if the shape descriptor is 16 8-bit integers, I8, X16, then you have to immediately provide 16 8-bit integers following the instruction. So, yeah, hopefully it looks like I can avoid actually caring about this too much. I just need to add the bare minimum necessary to allow it to parse this, because it doesn't have to assert anything about it. It just, the parser has to deal with it. But I think it is just these because of this. It says latest commit yesterday. Oh, so hold on. Is this... How new is this? I mean, it says it was merged yesterday. Okay, I'm confused about that because I didn't notice any changes to those files, but so this looks like this is brand new, this problem, which would suggest that this file would have passed if this hadn't been merged yesterday. But there we go. I mean, I assume this is the copy of the file I've got. Let's just have a look. Spec core, test core, linking, v128. Yeah, wow. So it's weird because when I when I pulled upstream changes, both today and yesterday, I didn't notice any changes to the files that I was going to be using, but obviously I missed this one. Anyway, so what we've got to do is implement v128.const, and specifically we only have to implement this flavor of it. So let's just do that. Who is complaining? Parse normal instructions. So yeah, first we've got to I'm not going to be able to use any of these existing parsing strategies because it's special, like select and call indirect and stuff. So let's give it its own special clause down here. So in v128.const. Oh, actually, hold on. It should probably be treated as a numeric instruction, shouldn't it? Type bits operation. So I think I should probably add v to the type. So it's either a floating point instruction, an integer instruction, or a vector instruction, and the number of bits is either 32, 64, or 128. Obviously, only some combinations of these are legitimate, which is something to think about. You know, previously, any combination of f and I goes with any combination of 32 or 64. Yeah, maybe that's too much of a bad thing. So what happens if I say either this or v 128? Because I think that better captures the situation. It's like either it's an F or an I with 32 or 64, any of which is fine, or it's going to be a V with a 128. Does that work? Okay, key not found V. So let me just check that bonkers regular expression hasn't broken anything. It doesn't look like it. So, you know, I'm a bit paranoid about this because this is the thing where it's like, oh, pattern matching doesn't let you reuse. You can't like have this sort of alternation where it's like, oh, either this side matches and you get type and bits, or this side matches and you get type and bits. But of course, regular expressions do let you do that. So this is fine. Okay, don't need to run all of that. So now I assume this is blowing up inside parse numeric instruction because it doesn't actually know how to parse one of these V Yeah, look, inside parse numeric instruction. So I need to teach this about vector. And yeah, the bits is always, that's always fine. It doesn't know what to do with vector. In this pattern match, right? So if it's a const, then, right, so this is cool. So we've already got the implementation of the const operation. But now we need to say in vector, parse vector, and then that's fine. Yeah, this is actually quite nice. Like, obviously I haven't implemented parse vector, but I think this is being wired up in the correct way. You know, this is going to return a const whose type is going to be colon vector. So it's going to be a symbol saying that it's a vector const. And then bits is going to be the integer 128. And then the number is going to be whatever we parse here. And like I said, I think I'm just going to support, well, it really doesn't matter what, it might as well return 0. But it just has to, it has to successfully parse the correct number of things here. So I think I'll probably just do a special case. So there's a parse integer, parse float, and now let's do parse vector. And bits is always going to be 128 here because that's all that's supported. So I'll say, you know, raise unless bits equals 128. Raise unless, well, let's do read into, so the next thing it's going to do is read the, whatever it's called, the shape descriptor. So let's force the shape descriptor to be I64X2. And then let's read 2 zeros. Because this is all we need to support for this. And then let's return 0. Because that is two 64-bit zeros packed together into 128 bits is a 0. And obviously I could implement this, but why should I? So let's see what happens when I do that. Oh. Stack too deep. Oh, in the interpreter. Okay, what's going on? Where's this getting stuck? Call index 1. Oh, so, I mean, is this an unrelated problem? I mean, yeah, this would have been useful to understand, wouldn't it? It's like, do I have any other problems? So Yeah, this is what I should have done to begin with, actually. So yeah, hold on. Let me just... let me stash what I had there. Let's think about this first. This would have been the wise thing to do, is sort of revert that change that was made yesterday, apparently, and then see whether it otherwise works. No, it doesn't. Okay, so it looks like that was like a successful attempt to... that successfully papered over the vector instruction problem, but now we've got another problem. So I think if I pop that off, yeah. Let's just check. 356, stack level too deep. So I'm fairly confident that this isn't vector instruction related. So I think I can probably just add this stuff. I'm just trying to think how fine-grained to make this, but I think I'm going to go as fine-grained as I feel like I can get away with. This is a self-contained change, and this doesn't break anything that is already working. So this is like support. Well, let's say like recognize v128.const as a numeric opcode in AST parser. Yeah, I think that's fine. And then maybe I just add the rest of this. So this is saying like support parsing v128.const i64x200 in parse numeric instruction. And I'll say this is the only vector instruction which appears in test core star.wast. It appears to have been added yesterday. Where was that? So I'll link to the culprit here. So it's not worth trying to implement. So it's not yet worth properly implementing the instruction in general. the one occurrence in, is it linking.wast, uses i64x2 as its shape descriptor. So here we read 2 zeros, 2 numbers, actually zeros, after reading the instruction and shape. Okay, I think that's okay. This is the only vector instruction which appears in those tests. I was only added yesterday. Oops, I just realized my brackets are mismatched. So it's not yet worth properly implementing the instruction in general. The one occurrence in linking.west uses i64x2 as its shape descriptor. So here we read 2 numbers, actually zeros, after reading the instruction in shape. Okay, so I think that does deal with that problem. But now we've got to deal with this other problem. So actually I'm going to copy linking.wast. And then let's have a look at it and try and figure out what's going wrong. Because so it prints 1 green dot, and then it seems to dive off into this, what looks like an infinite loop, and then we exhaust the call stack. So I think this first assert return is working fine. There we go. This second one is not working fine. Stack level too deep. Okay, so, well, that's easy then, isn't it? So this is our minimal reproduction of the problem. So this is defining a module whose ID is MF. It then registers that under the name MF so that it can be imported in NF. Oh yeah, I fear that this is going to be... Oh, this is not going to be straightforward, I don't think, but I'll just give it a second. But I fear that this is going to be a problem about functions not knowing which module they live in. So when we execute a function, we don't know what the current module is. Okay, but let's try to understand. I think maybe none of those are being used here. Oh, am I wrong? What? What's this? In invoke function, no matching pattern error. What the heck? I'm unsure what's going on here. This is concerning. Invoking function.inspect. Invoking function nil. So do I misunderstand what's going on here? I'm not even sure what this means. Call mf.call. I mean, I assume this is used somewhere else. Yeah. So that's supposed to be invoked somewhere else. So this should all be irrelevant. This should be everything that I need. So this function m, it exports a function called call. And what that function actually does is it calls g, and g returns 2. Then module nf declares a function called f. Oh, it imports call from this module, calls it $f, and then it re-exports that under the name mf.call. So this here should be calling it and getting this too. So there's a more fundamental problem here. Maybe the thing that I said when I groaned is not the case, that actually I've just gone wrong with my imports and exports somewhere, because this shouldn't be saying invoking function nil. So yeah, I guess that the imports and exports aren't getting hooked up correctly here. Did I? Yeah, that's up to date. Don't need the preprocessor anymore. Don't need the unit test for the preprocessor anymore. Don't need the parser anymore. Yeah, this is what we're worrying about. We're worrying about the interpreter interpreting this. So somehow when this call is happening, call $G. I mean, that's correct. It's calling function 1. Oh, maybe I'm right. It's calling function 1 in the wrong module. Yeah, okay, let's think about that. Calling function index in module, current module. Yeah, so I think it actually is the problem that I was talking about. Calling function 1 in module NF. So yeah, it is indeed the problem that I was worried about. So the problem is when we're evaluating the body of this function, this g has gone away. This just turns into a 1 because g is function number 1 in this module. This is function number 0. So this is just saying call function number 1. But because at some point when we begin, this is the current module, we never update the current module to reflect where that actually came from. Oh God, how am I going to deal with this? It's amazing that this hasn't come up. Like, it's amazing that so many of them, that all of those tests are passing, and that it's only this linking one that is actually exercising this, because it seems like a very fundamental problem that when you import a function from another module, all of its, at the moment, I'm trying to resolve all of the indexes relative to whatever the current module happens to be. Like, when does the current module get set? Every time we read a module command, we set the current module to be the most recent one. Oh, when we do invoke, we set it to be... Okay, so I suppose this is actually what matters. When we do invoke and when we do assert return, that's actually the important bit, isn't it? Is that if we're invoking a function in, in this case, we're invoking a function in NF, and so it's actually not the recency of this having been defined. It's that when we say invoke a function that is exported from NF, we set NF to be the current module. But unfortunately, what it's exporting is actually from MF. So how on earth are we going to track this? Like, do we need to, when we... God. I mean, one way to do it is for functions to just store what module they were defined in, so they're almost like a closure that closes over the environment where they were defined. Let me try that. Like I can think of a few ways of doing it. You know, we could, I mean, really, there's not very much in it. Either it's stored internally inside the function as like a sort of closure, or we have to pass it around with the function. So when the function gets exported from a module and becomes an import in another module, we need to just record like where was this imported from. And actually that needs to be transitive as well. So if that then gets re-exported, we need to export it not and say, oh, it's actually not coming from this module, it came from that module. But in that's really no different than just storing it inside the function. I think we probably do need to store it inside the function, because then the data flow of like however many times that function gets exported and then imported and then exported and then imported again, when it finally gets called, we have that reference all the way back to the original module. And I think trying to do it sort of out of band, where that information gets kind of flows around with the function, just feels like a much more complicated way of achieving the same thing. And if we did that, it would mean that we don't need to explicitly set the current module, because we can look up this export and then just invoke it. And like the act of invoking a function would involve temporarily setting the current module to be the right one. And then, yeah, we'd have to restore it again afterwards. So it's going to need another sort of call stack type. Like I've done in several other places, it's going to need to temporarily reassign the current module, which is a piece of state of the interpreter, and then restore the old one when it returns from invoking that function. So if we end up bouncing between several different modules, that functions that are all calling each other between different modules, then we're going to keep track on the Ruby call stack of like, well, what's the current module for the function that we're currently executing. So it sort of becomes part of the activation record, the sort of the stack frame, which we haven't reified. Like there's no explicit data structure for that in this program. I'm just using the Ruby call stack at the moment. I'm sure the spec has got something to say about this, because this has to be part of the sort of the definition of the abstract machine that this is supposed to be executing on. But I think I feel like if I start digging around in the spec, then I might get unstuck in, I might lose my thread and, get distracted. So maybe what I'll do, so at the moment we don't have any representation of functions, do we? We're just using the ones from the AST. Oh, God. Yeah, and there's a problem tying the knot here, because we build, at the moment, I think build functions. The tying the knot problem I'm referring to is that the module doesn't exist at the point where we build the functions. So there's no way for me to pass in, here's what the current module is, and have it bound up in, even if this was to build some kind of runtime representation of functions that remembers where they came from. I don't have an instance of the current module yet. So I think this reminds me of this stuff about module being immutable, because I think it's no longer helpful, really. Because really what I should be doing is making the module first, and then start assigning stuff to it. So like I build its functions and I tell those functions you are being built for this new module instance, and they can hold a reference to that module so that when they get exported, they know how to phone home. They know where they live. That doesn't make sense, does it? So I'm just thinking about what order I want to deal with this in. So yeah, what does build functions do? So all it does is pull in the imports and then concatenate it with the function. What are these? Just function bodies? No, these are the function definitions. I think. Yeah, so it's one of these. So it has a type index and locals and body. So that's what it's doing here. Okay. So sorry, I'm being very slow here, but it's just doing my head in a bit. If I had a function here that was, let's make it a struct for now so that it's mutable, so that it's got a definition, which is the AST node that defines it, and also has a module. Is that okay? Yeah, I think so. The module where that function is where that definition lives. In fact, for now, let's just see if I can introduce this. Can I just get away with this? So let's make this. Because if I can introduce this, then at least I've got a wrapper, a place where I could, in principle, store which module this function belongs to. And actually, if I do this, then there's the tantalizing possibility of like defining invoke here, but let's take it one step at a time. So if I did this, then all of these would be like that. Same thing here. So I'm just trying to see if I can insert, basically what I'm doing is just using this as a completely empty wrapper around the idea of a function definition. I'm pausing to think about whether definition is the right thing to use there. It'll do for now. I mean, it's probably not right. So let's just look at, okay, so that means that build functions would take these function definitions from the AST, and then here, instead of just adding them on, it would be functions.map, function.new, definition, that. Which I think is, yeah, it's sort of similar to this, right? This is instantiating globals. It's just that the globals don't have anything interesting in their definition, which is not true. They have their, yeah, maybe this is what I should be doing. Last time I had this problem about the mismatch between build globals and initialize globals, or whatever it's called, and it's because the global becomes unmoored from its initialization expression, because that we don't hold on to the definition of the global at this point, but maybe we should. So this makes a new function. I mean, this should break everything, because now, yeah, we don't know how to invoke functions. So where do we get stuff? Okay, so build exports this is just going to be an array of function objects. So it doesn't know anything about the internal structure of those. It just knows that that is the array of runtime functions. So that's okay. Here they just get stored on the module. That's what we just did. We built them. Like I said, yeah, it just slices them out here. Oh, I forgot to refactor this. Refactor interpreter build exports. Oh, this is the one word that I reliably mistype more than anything else. It's so strange. Okay, so I think functions are essentially opaque. It's only invoke function who knows what to do with them. Oh, we can push references to them onto the stack, but that's okay. Okay, so it is, I think, just invoke function that gives a shit. So here we can say definition equals function.definition, and this can be case definition, not destination. I think that should be enough to fix it. Or at least fix that small change that I made. Oh, that's not right. Function.typeIndex. Okay, hold on. Oh, of course. When we actually try to why do we think we need the type here? Oh, it was just for this, wasn't it? So, you know, I'm not sure that this is important, but let's just go for it. I think maybe I put this in because I thought I was being clever to use the type from the function definition to decide how many results we should pop off. But previously I was just using the number of expecteds for that. So I think maybe I should just go back to doing that. To decide how many values to pop off the stack in assert return. I thought I was clever using the function type to do this, but in hindsight, that seems overly complicated and couples the implementation to the representation, or to the runtime representation of functions, which is unnecessary. So yeah, I think that was probably a bad decision that I made there. Okay, any other problems? Yep. Oh, so here's a function that has been passed to invoke function, but it hasn't been oh, this needs to be AST function, because that was, otherwise that was referring to the, let's just see, do I have any other references to that name? No, it was just that one. Okay, cool. Okay. So I think this is a step in the right direction, because now I've got somewhere where I could, in principle, store in each function a reference to what module it belongs to. Okay, that seems to be working okay. So what would it take to give this that? When I make a new function, yeah, I mean, here it doesn't matter. You know, this, for all I care, this could be like module nil. Because it doesn't need it. You know, there is no representation of the spec test module. Although, you know, maybe there should be now, but that's not the problem I'm trying to solve. So yeah, I can't just provide the module here because it doesn't exist yet. But maybe I just should. You know, either what I need to do is instantiate the module earlier and pass it into build functions so that it can be, it could be part of the sort of the closure essentially that we're creating with those functions, those function objects, or I need to make the function objects mutable, and then after the module has been created, you know, there could be like an initialize functions here. I think it's all part of the same problem. It's all part of this problem, the immutability problem. So I think what I'm going to do is keep doing what I've previously done and have a sort of initialize functions. Actually, I don't need to pass anything in at all because that just is just going to use current module. I assume that, yeah, these things all rely on current module having been set correctly. Okay, so I think let's make a commit and lock in what little progress I currently have. Okay. Oh, rubbish. Okay, I want to see that. I want to see these tests run successfully, but all that printing out was making it go way too slow. Hopefully I haven't missed. I mean, this is only a small number of places, but I think these are the only places where runtime functions actually get created. And previously it was just copying them from the AST, and now they're getting wrapped up. So my commit message is going to be something like wrap up. Well, let's just say introduce runtime representation of functions. And then the commit message is going to say basically, at the moment, these just contain the AST node for the function definition. Well, this is looking okay, so let's be optimistic and do that and say, at the moment, these only contain the AST node of the function definition. But soon we'll add a reference to the containing module so that exported functions can still be invoked in the context of the correct module versus the module they were imported into. Well, let's say rather than the module they've been imported into. Okay. I'll just let those tests finish before I do anything else rash. Okay, so we didn't break anything. So let's say all this is going to do is just say current module functions each do function function.module equals current module. And that is not going to work at present. Because they're immutable. So let's now switch this up to a struct. Why's that happened? What the heck? what? I'm confused about what's going on. Oh, so we already had this problem. Okay, so, okay, what? So invoke function is being called with nil here. Is this different to the problem that we were seeing before? No, I think we were already calling it with nil. Yes, because there aren't enough functions. Yes. Okay. It's. I know I was literally just working on this, but it's because this is referring to function number one, and there is no function number one in here, so we get a nil. So it's like this is broken in the correct way. But let's run something that is supposed to work. You know, maybe I should run something like call.wast or something, just to check that function calls work correctly. And so far, I don't appear to have broken them. So you've added like the parent module to a function, and for every function, we've set the current module. So let's just I mean, ultimately what I want to do here is say like previous module. Well, actually, this just sort of gets splatted all the time, doesn't it? So I could just here when I come to evaluate expression, oh look, it's up here when I first say current module. I just need to do self.current module equals, well, let's do it up here. Function.module. So that hasn't broken call. But it also hasn't fixed this. So this is invoking this function with a call, index 1. Oh. This is so stupid. So the thing that I was... oh. So... what I'm doing is going through, my approach is never going to work, because what I'm doing in initialize functions is just going through and making all of them point at the current module, but that will include any functions that have been imported. So this is just overwriting that record of which function of which module they came from. I mean, that's the only thing I think that could fix it. Right, so that works. This is saying, like, if this function doesn't already have a module, then make it be the current one. So that's a hack for making it ignore anything that's been imported from another module that has already been instantiated and therefore has already sort of claimed that function. But that's really gross. To do assign module at function creation time. Maybe I'll just leave it like that for now, because that does actually solve the problem. Oh, wow, it doesn't solve this problem. Okay, hold on, this. So we do actually get a pretty long way, though. So what's the problem here? $MT. I'm going to look at this to just help me to understand what I might have overlooked. Oh, so do tables somehow have a related problem? Tables contain func refs. I mean, I guess this is what this linking test is all about, right? Is trying to make all this stuff actually work. And I haven't thought about how to make it actually work. So this is ostensibly for tables. So I maybe haven't thought about how this works in the context of tables. So again, maybe I need a sort of a minimal reproduction of this. I think maybe there is a problem not restoring the previous. This seems risky to me. Maybe I'll do this in here. Same deal as here. Self dot current module equals previous module. Does that magically fix my problem, or do I have a different problem? No, it doesn't magically fix my problem. That's unfortunate. But nonetheless, it felt a bit wrong to be, because invoke function could happen by like as a result of a call instruction. And so we only really want to update the current module for the duration of that call instruction. So I think I'm gonna see, I only use with tags once, so I should probably have a with module. I should probably, you know, I'm wrapping this up. Previous module, current module. So this would be with module function dot module. I mean, here it doesn't need to be current module, does it? I would say this should be function dot module, and then that can live outside of this. In fact, it's really only this that needs it. It's just evaluate expression. Everything else in here is kind of aware of the fact that this function lives in a particular module, so we can look in that directly. It's only inside evaluate expression. Like once we pull the body out and we're just evaluating an arbitrary expression, we've handed off control to something that doesn't know about the function definition anymore. So that's the point at which we have to set the current module, I think. So let's just see. So yeah, I mean that, I think I've got enough for a commit there. Like this does get us somewhere. I really don't feel comfortable with the way that this is working. But I can't think of a tidy way to make it work otherwise because of the order of operations we have to do here. Like we can't, at the moment, we can't build the module before we instantiate these function objects, so we have to come back and do this afterwards. And by the time we get here, we've forgotten where each function came from. Okay, well, let's just go with this for now. So let's do this one first, because then that's something I can talk about. Store parent module on runtime representation of functions of a function. Store a function's parent module on its runtime representation. And then I'll say, sorry, Etienne, we need this so that we can properly set the current module when evaluating the body of an imported function, all of whom's identifiers will refer to things inside the module where it was defined, rather than necessarily the module into which it's been imported. Don't need to say necessarily. I've already said it's imported. The hack in initialize functions is intended to set the current module only if a function doesn't already have one, since that would imply it's been imported from another module whose functions have already been initialized. This is pretty grim, and it'd be much better to just set each function's parent module when it is created. But at the moment, we don't create a module until all of its functions have already been built. So for the moment, this is the easiest way to get the parent module association working. In future, we'll need to go back and tidy this up, since it's quite messy. Okay. And this one is going to be basically, yeah, use functions parent module when evaluating its body. I don't think I've got anything else to say about that. Well, it should really be. Retrieving its type and evaluating its body. Yeah, because those are the two things we use it for. This is where we retrieve its type. This is where we evaluate its body. I don't think it's worth having two different commits for those two things. Okay, so I think I need to take another copy of linking.wast. It's failing around the MT situation. So it's in here somewhere. Is this good so far? Oh, okay. That's strange. Okay. Is it something down here? No. God, how far down is the problem? If only I had line numbers. Okay. So is it this one? No. Is it this one? Yes, this one. Ugh. Okay. All right. So presumably I can skip all of these assertions and it's not going to be a problem. Assert trap doesn't matter. Just ignore that anyway. We still, yep, still broken. Get rid of all of these. Okay, so all of these assertions. All of these. I know I should have just read this code in order to understand what was going wrong, but I'm just trying to do as much mindless stuff as possible before I actually engage my brain. I need to conserve the thinking juice. Okay, so look, there's loads of modules here. MT, NT, QT. Surely this can't be involved. It is not. Is any of that involved? Sort of looks like it isn't. Yeah. So this is just invoke MT, call. So hopefully that's not being used for anything. Well, none of this seems implicated in the problem anyway. What about this? Okay, so this is actually quite a localized problem. It does look like it might be table related, doesn't it? So what do we do here? I don't think this registration is even used. So it's just some kind of basic failure to look up a function here. So how's this supposed to work? You know, I assume here that if this was just i32.const 0, it's fine. So it's the call indirect that's not working. So this is trying to go through the table. And it's going to 7. So let's maybe do some debugging. So the table's got 0, 0. So maybe I'm making some kind of category error here because it looks like this lm is initializing like, my hesitation is, how's this ever supposed to return 0? The entries in this table, it starts out with 10 entries, I think. And then entries 2, 3, 4, and 5 get populated with references to this function g that returns 4. And it exports this function h that returns -4. So this is trying to get the function at position 7 in the table, which is indeed nil. So like, at what point is it supposed to be possible for this to be 0? And this does export this table. So maybe we should be looking at like when and how does this table get updated? So this is an imported table. And this writes I and H into the table. H returns -4, so that's not relevant. I don't know if this is a function that, I mean, this is a function that doesn't return anything. This puts this function that doesn't return anything at offset 9. Okay, and then oh god. All right, so this is testing. This assert return actually depends upon what's happening in this assert trap. Because the idea here, like, okay, yeah, so I hadn't appreciated this at all. But what this is testing specifically is that we try to instantiate this module and we get most of the way there, which includes sticking this function f at offset 7 in that table. I mean, I think my theory is that if I were to copy this, so this module here, if I allow it to just insert this function f at the appropriate offset in that table, then that passes. So, but unfortunately, because we're ignoring the assert trap, and I mean, I think that if I put this in, if I uncomment this, well, yeah. okay, it doesn't, at the moment we're not doing bounds checking on the table, which is why assert trap can't work properly. Oh dear. Yeah, quite a twist. Thanks, Chris. So I think, so basically everything that I've implemented is working correctly, but the problem is that this, there are tests. Like, yeah, I mean, it is a twist. I had no idea that this was coming. There are tests that will check the state of the world after a sort of a partial failure. So this module instantiation, even though it fails, it has a side effect, and then that's what we're testing here. So now I understand why it's broken. I have to decide what to do about that. And unfortunately, I can't think of anything to do about that except evaluate all of the assert traps. And so, hold on. So let's try that. So, let's pick a test. Yeah, so Chris asks, how many assert traps are there? It felt less common than assert invalid. That's a good question. Let's have a look. So there are rather a lot of them. I mean, I don't object in principle to evaluating them. I mean, I'm going to have to evaluate the body inside like a rescue, because the whole point of them is that they do wonky stuff, and they're going to cause the interpreter to do wonky stuff. You know, they're going to, I mean, in some cases, the interpreter is actually not going to do wonky stuff because it's, you know, we're not checking the bounds of memories and tables and things, but that's okay. It's just in cases where it does, where the assert trap does break the interpreter, we're just going to need to rescue from it. So yeah, there's rather a lot of them. Let's pick, I want to pick one that already, I mean, maybe address.wast is a good one. Right, so that's currently fine. Yeah, who would have thought that the side effects of this were going to be important? Okay, so look, there are a few chunks of assert traps inside here. So let's just play around and see what happens. So in order for this to work, I'm going to need to actually support assert trap. What is the syntax of assert trap? I hear you ask. And to that I answer action failure. Okay. And it looks like it's always just a string, right? So in the parser, let's actually parse it. And remove it from here. Basically, it's going to be pretty similar to this, but this is going to be assert trap, action. The action bit is going to be the same, and expected, instead of this, it's going to be failure. And I think this is just going to be parse string. Yes. Yes. So I think that's all correct. So now I'm expecting the interpreter to freak out. No matching pattern error. I don't know how to deal with an assert trap. Chris asks, do you know about how traps work outside test scripts? Can you catch them in WebAssembly? I do not know. My understanding of them, though, is that they're sort of like panics rather than exceptions. I don't know what I'm basing that on. Let's have a look. Doesn't say anything about traps in execution here. Oh, maybe they'll be under values. Maybe if a trap is a kind of value. No, it doesn't look hopeful. So a result is the outcome of a computation. It is either a sequence of values or a trap. Okay, administrative instructions. The trap instruction represents the occurrence of a trap. Traps are bubbled up through nested instruction sequences, ultimately reducing the entire program to a single trap instruction, signaling abrupt termination. So, like I said, that I think that's sort of like a panic. It's like a halt instruction in the abstract machine or whatever. So like, I don't think there are exceptions, basically, is what I'm trying to say. This is just like an abort that causes the whole abstract machine just grinds to a halt. So I'm not actually going to be checking for that. I just want to be able to tolerate the execution of whatever the assert trap is trying to do, because it turns out that the side effects of that are important, and I just got to make sure that that doesn't break anything. Okay, so it looks like I've parsed it successfully. So assert return. I mean, I'm sorry about this, but I'm just going to have to copy that whole thing, aren't I? So invoke is up there. Yeah, I mean, does assert trap, is assert trap always followed by invoke? I mean, in principle, no. But in practice, it would appear yes. Because why would you wouldn't do assert trap get. That would be silly. Because the only way you can get a trap is by evaluating instructions. So I think it's probably okay for me to do something a lot simpler here. I think I can probably basically hold on. In assert trap that has an action and it has failure, which I'm basically going to ignore for now. And I mean, let's just inline that we only support invoke here. I think that's what I wanted to do, because then I can basically just copy. What am I doing? Let's copy this. Thing is, I don't want it to be here. I want it to be after assert return. That's why I'm faffing about with that. But basically, I'm going to stick it here and say, like, if we've got an assert trap, well, firstly, let's just see what happens here. So, let's just like print an interesting dot. All right, so we've correctly found all of the assert traps, and we haven't had a pattern match failure for like, oh, but there's an assert trap that's doing something other than invoking. So that's good. So I might actually let this run through just to check that there aren't any other assert traps lurking that I'm going to have to support. Excuse me. Because the next thing I'm going to do is invoke the function. Yeah, arguably there's no point in setting the current module before invoke function now. Because that will always set the current module. So maybe that's... Yeah, maybe I should make that change actually before I completely forget about it. But let's continue on this investigation for a second. Let's just say remove redundant current. Oh, crap. Data.wast. Unhandled exception. What's happened? Is my terminal crashed? I mean, that's not good. Okay. Yeah, I'm gonna force quit my... Oh no, hold on. It's come back. Just as I was about to force quit it. Okay. Well, I don't know what happened there, sorry. What the heck? So that's actually a parsing error. Assert trap, invoke, get, raise. Okay. So what on earth does data.wast have in it? There clearly is something that I wasn't anticipating here. What? Oh, I mean, I guess this is this is exactly the sort of thing that we were... This is exactly the kind of thing that we're supposed to be doing. I'm sorry, I'm being very inarticulate, but this is what linking.wast does, right? It's got like an inline module definition there. So an action... Oh, right, look. Assert trap module failure. Assert module traps on instantiation. Okay, so there are two different flavors of assert trap. God. All right. Well, I think what I'm going to do is just crowbar Have I got like parse module? Yeah, so I think I'm just going to do that. So either, well, okay. Let's make it a little bit less. Because I can see that the rest of these are being quite polite. So this is going to need to be inside read list. Okay, so the action, I know it probably shouldn't be called action because it's sort of action or module, but I'm just going to crowbar those in and say that the action can be a module, in which case the implied action is to instantiate that module. In which case, perhaps I can get away with only doing that kind, because that's the only kind that we actually care about. Now what? Okay, what? I32, no matching pattern error. Parse normal instruction. I32. I mean, is it fine for the parsing to fail? Oh dear. I assume this is happening inside parse module somewhere. Script, parse commands, parse text, yeah. So yeah, inside parse assert trap, we've gone to parse module. So let's say parsing module. So at least we can see where the failure is there. Oh, damn. Okay. So I think the problem here is that the preprocessor doesn't the preprocessor doesn't touch what's inside assert trap, and actually it does need to, because the problem is that there's an import here, and the parser thinks that that's syntactically not valid, I think, because I took out support for inline imports. So it thinks that this is an instruction, but it's not. This needs to be desugared. Oh, what a pain. All right, so next, let's start a new recursive rabbit hole, which is teaching the preprocessor to go inside assert trap. So process command. If the command first is in module, then process module. If it's in assert trap, then process assert trap. command or something. Well, I suppose we know it's an assertion now. So what do I want to do in this case? I think if it's only if it starts with a module that I care, right? If it's anything else, then I'm not interested. So yeah, it's like this kind of thing. Case assertion. Dear sir, so if this assertion is in assert trap, and then there's a module, and then there's a failure, otherwise we're just going to leave it untouched. But in this case, we're going to, do something there. What is the something that we're going to do? Is it just that we're going to process module here? I think perhaps that's enough. So this is just doing pre-processing on the module. I think that should be okay. Well, we got further, I think. Previously it was failing on this import global I32 business. And that seems to have been dealt with up here, because now it's turned into an explicit import. Okay, but then something else has gone wrong. Well, the parsing has all succeeded, but something's gone wrong here. No matching pattern error. Assert trap. Oh, right. Okay, well, this is expected, isn't it? This was supposed to happen. Basically, I think what I'm going to do here is I'm going to have two different flavors here. If the action is instantiate a module, then we're going to do something. Yeah, okay, fine. Wow, okay. Okay, so what was I trying to do? I was trying to check, and I'm glad I did, because I'd completely forgotten about the whole point of what I was doing, which was being able to handle these. So all of those assert traps that are just invoking some function, those are still being skipped, because at least right now, I don't think that I care about that. I don't think I need the side effect. It was only the side effect of this assert trap that does module instantiation that I need. So have we seen any blue dots yet? No, I should be paying attention. But hopefully when we get to data.wast, we will see some. It feels to me as though these tests get slower as the stream wears on, but maybe that's just a purely psychological effect. The first time I run them, they're very quick. Okay, look, so look, data.wast, lm.wast, they contain some module instantiations. Are those the only ones? It certainly doesn't seem to be the norm. Can't see any there. Chris asks, so is there going to be a test that makes sure code after a trap doesn't run? Yeah, probably. There probably will be. Whether that is going to scupper me here, I don't know. Okay, so I didn't see any other blue. Yeah, it's a good point, Chris. I expect that there probably will be tests that traps actually, you know, the execution doesn't proceed past the point where the trap happened. I hadn't thought about that, but hopefully for this, it's going to be okay. So I think the only ones that we saw actually were here in data and LM. So that bodes fairly well, I think. Oh, damn. Right, so there's another layer to the rabbit hole, which is that we can't even parse this module because it includes a start field, which we don't support yet. So I'm going to have to add support for that to the parser so that we're able to successfully parse this assertion. Okay, that's all right. Let's just keep digging. So I did mention this briefly before, that start is a way of nominating like the main function in a module, and I believe that so a start function, so yeah, at most one start function may occur in a module. So you can have this that says, well, there's a function called $foo, and that's the start function, and then that is automatically invoked when the module is instantiated. So I hope this is asserting that the start function actually executes. But I hope it doesn't matter if I just ignore it. It doesn't seem like store is modified if the start function traps. Right, yeah, so this is all just checking. I think if I ignore the start function, then module instantiation will still have happened. So this is all about, I can see, there are more tests here which are about side effects of module instantiation. So it wasn't just an isolated incident. We're going to need other places where the module gets instantiated. But I think it's okay for us just to ignore this. But we do need to parse it. I'm not going to add it to the AST because I don't need the interpreter to do anything. So I'm just going to add support for it in parse text fields, which I assume was the place that it blew up. Yeah, there we go. So is there some kind of canonical order of these things? No, we're all over the place. Okay. Func memory table global type data export import lm in start. Repeatedly read. So this is just going to ignore the start function, I hope. All right, so we're back where we started. So we've successfully parsed the whole function. There are only two, it turns out, assert traps that define a module. This one and this one, but we need both of them because there are assertions that depend on their side effect. So wow, I've got a lot of stuff to git commit after I'm done with this, but this whole thing has been a little bit exploratory because I wasn't sure what the right thing to do was. So here, the action is a module. Oh goodness. So okay, I really apologize for this, but I'm just going to copy all of this because this is module instantiation, right? Maybe this would be a good point to extract this. Can I do that? Ah, yes. Look, it does freak out. So module instantiation does, in fact, trap. So that's good because that's what it was supposed to do. I mean, it was supposed to say out of bounds memory access, but instead what's happened is that down in the guts of the memory implementation, it's saying that because the bytes are stored in a string, it's indexing outside of the string. So that's sort of good news. So let's say oh no. So I think we got a bit further. Damn, I felt excited there because I thought we'd actually got somewhere. So hold on, if I stash all of that and we run this again, it got that far. With all those changes, it does get a bunch further. But why not? God, okay. invoke load i32 327670 expected 0. Okay, it's this one. So it sort of seems like I mean, we're so close to the end of this now. So what is this expecting? Expected 0 got 122, which I think is a Z. So maybe this is to do with the semantics of the bounds checking for an active data segment, because am I right about 122? Yes. Okay, so the Z, this is decimal, right? Yes. So this Z, so sorry, I should be more articulate. This is trying to write this string of Zs into the memory. And this is checking that it hasn't. This is saying that the memory should have been initialized with all zeros in it. Right at the beginning of the memory, we write ABC, and that's what this is checking for. 97 is ASCII A. So it's checking that this active data segment did get written into the memory, but that none of this did. But it says partially out of bounds. So I think my implementation is like copying this in one character at a time, and it only traps at the point where, you know, if this, you know, if it was like this Z that was problematic, it won't write that one because that raises an exception, but all of the earlier ones will have been written in. But what this suggests to me is that I need to raise an exception. I need to not write any of these if it would take it out of bounds. So I am going to have to do some bounds checking. Oh, this is so stupid. I can't believe how much I just can't believe how much of a rabbit hole this file is this test script is turning out to be. Like, this is really exercising all of the bits and pieces that I've ignored, and suddenly they're all coming back to bite me. But look how near to the bottom of this file we are. Like, this is so tantalizing. Okay, all right. So, okay. So hold on. Yeah, you're right, Chris. I could commit what I have. That's a good point. Okay. Yes, I've strayed too far from the path of of committing stuff as I go, because I think you're right. It's long since been true that I've made progress here. So let's add. Yeah, I think there's a commit that I can do here that's about adding assert trap. So like I add it to the AST. Not that. I add it to the parser. Let's just add, you know, this is the sort of the fall through for assert trap that just prints a dot. In fact, can I? No, I'll leave it as separate. I was going to say I could just combine it with the skipped assertion, but I'll leave it there. That's a separate problem, right? So the separate problems I've got here are making the... Oh no, this is all of a piece, isn't it? Because I can't successfully parse it without going inside it. Okay. I can't commit what I've got here because this will break the tests because it can't successfully. So sorry. I need to add the preprocessor change first. So this is desugar module definitions inside assert trap. And we can say we need to be able to parse these so that we can perform the module instantiation inside, so that we can attempt to instantiate the module inside assert trap, which is required, the side effects of which are tested by linking.wast. But before we can ask the parser to parse them, to parse assert trap, we need to make sure that any module inside it has been desugared, ready for parsing. Okay. Okay, that's okay. Now I can do what I just did. That, not that, that. Not all of this rubbish. And then what's left is, yeah, actually doing the instantiation and the... oh no, I've forgotten whether we needed the start. I suppose I can do this. I just want to, I don't want to make a commit that's breaking anything. And now that the parser is going inside the assert traps of all of the existing tests, I want to make sure that there's no start inside them. I think it was only in linking where there was a start. You know, it was this one down here. But I just want to double check that. But assuming those tests pass, this is going to be parse assert trap. I suppose it should just be like support parsing assert trap assertions, basically. So yeah, I'll just let this finish. Um, and then, yeah, sorry, I'm rehearsing in my head what I'm going to do next, which is that I'm going to go in and figure out what is the code path that is taken when we are instantiating a module that contains an active data segment that then tries to write a string into the module's memory. And I just need to, I guess it's probably, it's almost certainly, okay, that's good. It's going to be calling one of the assertions on, not assertions, it's going to be calling one of the operations on memory, basically. And we just need to make sure that that fails earlier. Oh, why is it unmerged? I don't understand why Git was unable to handle that. Okay. So again, can I... Oh yeah, so I know the parser doesn't need any special support because I just ran all of the tests. So let's add just this one. Let's ignore start. What does it call it? Ignore start function when parsing module definitions. And I'll say one of these appears inside an assert trap in linking.wast. It doesn't need to actually execute, but we do need to be able to parse it. Okay. So my hesitation about committing this is that I think I probably should extract, you know, instantiate module. So let's just do that. This whole thing here will become something like instantiate module mod. And we'll do the same thing up here. And then all of this just goes somewhere else so that I can reuse it. Where's a sensible place for that? Maybe sort of near the top, like before of the build functions, build globals stuff. So hopefully so that's just extracting a helper. And then what I've stashed is also using it in assert trap. So this seems likely to be okay, doesn't it? Extract, instantiate, module, helper. We'll need to reuse this in the implementation of assert trap, which can contain a module to be instantiated. Okay, I'll let that run, but I'm going to say I'm 100% confident that that's fine. Right, so now we're just ignoring any exceptions, which is fine. But of course, this problem. So now I can think about what's happening. Let's see where it actually conks out. Initialize memory. Okay. So here we need to say like, so what does that look like? Raise if data string, is it byte length or something? Byte size? Implementation from string returns the count of bytes, right? Okay, so if data string byte size, oh, and this is also has an offset, right? If offset plus data string byte size is so how does this, how do we know how large this is allowed to be? I don't think we do. Excuse me. So hold on, the code here is calling store at some offset. And that was throwing an exception. So, I mean, I don't want to be completely cavalier about this, but I do also just want to focus on like what is actually needed at the moment. So this memory is imported from MM. Okay, so here's the memory from 1 to 5 pages, and it's Oh God. Okay, so I'm just trying to think about, so this 327670. So that's reading something 10. So this is trying to write 10 bytes away from the end. And obviously there's more than 10 characters there. So it's checking that this doesn't get written into it. Now, how did this memory end up large enough to even start writing an offset that large? Is what I want to understand. Like, what do we do with the maximum size? Like, I'm sort of surprised that it was able to write anything into this string at that offset. Unless there's some stuff that grows it. Oh yeah, indeed, there is some stuff that grows it. So maybe I can get away with just using the current size of it, I suppose, is what I'm slowly coming around to. Okay, so hold on, let me think about this. Hello, byte size 5. What's the ultimate operation that we do in we do set byte? How does set byte work? Oh, it needs to be right. Okay. Couldn't remember what the what the method was there. Okay, so I think so. Sorry, what I'm doing here is thinking about like off by 1 errors. Like what is the actual comparison that I'm going to do here? So this is going to be a problem if we are ever going to call set byte with 5. So 4 will be fine. But 5 is right out. Yeah. So, and that obviously that's the offset plus the, and that's 5 is the string, well, not the length, the byte size, which happens to be the same in this case because it's an ASCII string, but you know what I mean. It's every character is a single byte. So that means the condition here is if offset plus the data string byte size is greater than or equal to current module dot memory dot bytes. Oh, it does have a maximum size, but hold on. Is this right? No, it has to be greater, doesn't it? Because these 5 is not an index into this string. So if I was copying this string in, this has to be greater. Because if offset 0 and data.string is the exact same size as current module.memory.bytes, then that's fine. If offset is 1 or greater, then that's not fine. If byte size is any larger than this thing, then that's not fine. I mean, that's just obvious. I should have seen that, but I didn't. Okay. Okay, that's good. Unhandled exception. Because I didn't put the rescue in. Oh, yes. Okay. Okay. Linking.wast. Now passing. All right, so now I just have to... Thank you, Chris, for the party popper emoji to celebrate that. Okay, so... Oh, hello, James, and thank you for 3 party popper emojis. That was very enthusiastic. Wow, you are really spoiling me today. Okay, so that's all working now. So this can be instantiate modules inside assert trap assertions. And I'll just say we need to do this because there are assertions, well, because linking.wast contains tests that verify the side effects of module instantiation, well, of failed module instantiation, which fails partway through. Okay. And then I just need to add this and say fail fast if memory initialization is going to go out of bounds. And I'll say there's a test in linking.wast that checks the whole copy fails, not only fails atomically versus only failing once we try to write a byte out of range. So Chris says, probably a distraction. I feel like there might be a refactor in initialized memory, or at least in the future you might want to run a similar check when writing to memory. Yeah, I mean, at the moment there is just, this is the first piece of explicit bounds checking in any of this code, I think. Let's just have a quick look at what you're saying though. So what is the refactor in initialized memory, Chris? Like, what do I want to do here? I mean, I think part of the problem is that I shouldn't really initialize memory, shouldn't be writing these byte by byte. I think there should be a higher level operation inside memory that allows you to write a string at a particular offset. And at the moment, that sort of lives outside of the memory class, but I think it should probably be pushed into it. And then this bounds check would always happen. I think it makes sense for this write to sort of fail atomically rather than, you know, blaze halfway through the string and then conk out. Yes, should be encapsulated in memory, you say. I'm trying to keep my eye on the prize at the moment, so I think you're right, it is probably a distraction. Let me write it down. Move copy entire string into memory logic out of initialize memory and into the memory class somewhere. I mean, there is, you know, in this from string, you know, this is a special case, right? Is like this lets you instantiate it from a string, but actually this could be expressed in terms of that operation if it existed. You know, we could just do new and tell it the size, and then we could write the string into it. But that just doesn't exist at the moment. So yeah, that is definitely an oversight and something that I will definitely do at some stage. So this looks like that's dead. I think that's also dead. Okay, so I think linking is passing now, right? Like I got that wore me down so much that I think I can do this now. Let me run the whole thing over here. Wow, that felt hard. Look, it's our old friend, the start function. Okay, all right. So we're getting somewhere. Oh, skip stack guard page. What is that going to be? What the heck? Offset equals. Okay, well. It could be worse. This tests that the stack overflow guard page can't be skipped by a function with more than a page of locals. Again, this is another. This looks like another. This is going to be checking that I'm going to be doing some kind of bounds checking, which currently I probably am not. I mean, this is testing. This is making assumptions about the way that it's been implemented that don't even apply to what I'm doing, I think. You know, these thinking about there being a real stack here that you have to worry about, and the callies trying to. Well, no, maybe this makes sense. Sorry, I'm just talking nonsense now. Like, do we not support this? Where's the load? Offset equals 0x00. I think maybe I do support this, but like maybe not with hex. Let's see. Yeah, look. It has to be decimal, which is a bit annoying, isn't it? I mean, have I ever implemented this align? Like, I'm really not sure it does anything. Like, I store the offset, but I don't store the align. So again, quite how I've managed to get this far. Yeah, Chris says, that spec looks like a useful way to benchmark parser performance. Yes, I agree. I don't think this is going to be good. Well, I mean, you saw when it ran that the parser spent absolutely ages chewing through this. So yes, this is going to be a right stress test. Oh, look, actually, there aren't actually any assertions in here that I am going to execute. So all we've got to do is successfully parse this. So actually, the fact that the interpreter doesn't even know what the value of a line here is going to be completely irrelevant. I've just got to be able to parse a hex offset. So this is the only place where it happens. So let's say this is either, I just want to do this really quickly. This is either a load of decimal digits, or it's 0x and a load of hex digits. And I'm sure the same is true for a line. So let's see, text format, instructions, memory instructions. i64.load and store. What actually is this though? So it's i64.load. Offset, align. Offset is a U32, align is a U32, and both of these so I have parse integer. This is for unsigned integers though. Let's just wing this for now. So same thing here. Obviously, this is a huge nightmare. And then I think, okay, good night, Chris. Thank you for thank you for hanging in here. I apologize for not having given you the satisfaction of being able to tick all of these off, but yeah, unsurprisingly, it turned out to be harder than expected. But thanks for hanging out. I appreciate it. So now, oh yeah, this doesn't work. Right. So that does work. Okay. So it's just this same business, right? So if offset start with OX, then offset to I, offset. Okay. Okay. Successfully parsed. Let's just say support hex unsigned. Support parsing hex unsigned offset and align for load and store instructions. So support hex unsigned offset and align for load and store instructions. I think that's fine. And now that means that I can add skip stack guard page. Okay. 4 remain. Let's look at start. Failed. Okay. So at the moment, we're just ignoring this. But what we need to do is to call this function during module instantiation. So step 1 is going to be to remember this, and step 2 is going to be to honor this during module instantiation. So yeah, this one isn't supposed to be a vector. This is just an optional single start for a module. So there can only be one if there is one. And I think this is just going to be an index, right? Yeah, it's just a function index. So that's really all we need to store is an optional function index. So, oh God, it's still going. The thing is, I think it really does get slower. Like, this was never, it was never this slow to begin with. And now it's really crawling. I don't understand why. Oh God, I hope I haven't broken anything. I think maybe I have broken something. Because this is where it died before. I think there's a problem. There's a problem with lm.wast. I cannot continue. Oh no. Okay, well, abort. Damn. When did that happen? Why is it locking so hard? Well, obviously I need to investigate this, don't I? Um, um, okay. That's bad. That's good. That's good. Okay, so there was a problem here. So when we did this, instantiate modules inside a search wrap assertions, we became unable. I mean, yeah, it's really wonky, isn't it? Why is that? Why is it not even listening to that? Okay. Fine. Well, let's think about this. So it's doing 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 assertions before something bad happens. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I think if I stop at 13, I would expect to see one green dot before a bad thing happens. Oh, running the wrong file. Yes, okay, so that is at least what I expected to happen. So what the heck is going wrong here? Oh, look, I need to also so somehow so this -1 here is really causing a problem. So, I mean, I'm a little bit concerned about what's going on there, but like, what happens if I... What happens if I don't rescue this? Like, it just hangs... Like, that's not right, is it? Is that a bug in Ruby, or what? Like, storing value, inspect, at offset plus index. Oh, it's not even getting that far. How far is it getting then? I don't know what to make of this. Very strange. I don't want to get too bogged down in this. I mean, can I just like raise if offset less than 0? What the hell? What is going on here? That's fine. Oh, this is nothing to do with memory, is it? It's to do with tables. I'm sorry. This whole thing is a complete waste of time because it's initialized tables. Initializing tables inspect with elements inspect. So, okay, well, I could at least it let me quit out of that. I mean, is it because, I guess this is probably it, is that this is just a ludicrously large number. Like this -1 doesn't show up as a negative number. It shows up as like, you know, almost the largest possible 32-bit number. And so I think maybe that is what's causing the issue here. You know, like this number is massive. So I think I need to do some bounds checking here. So what is this? So element index offset items. So this is the, I think this is the culprit. Oh yeah, okay. Well, that's caused a different failure, but at least it hasn't caused it to lock up in that way. So let's see here, like puts offset is offset. Let's get rid of this. But I think this is the basic problem, is that this number is massive. Yeah. I don't really like it that it locks up the Ruby interpreter, but it's not necessarily wrong, is it? So how do we know how big a table is allowed to be? So a table's got a minimum size. How does table sizing work? Tables, all sorts of abbreviations, but what we really care about here is table type, which has got limits, min and max. Okay. So what is actually going on here? When we say table 10 funcref, that's saying that the minimum size of the table is 10 and there is no maximum. If no maximum is given, the respective storage can grow to any size. So why is this out of bounds? Oh, this is horrible, isn't it? Element segments. What is this? So this is an abbreviation that's just saying that the offset is -1. But how do we interpret the offset here? Like, this is a excuse me, this is a signed integer, right? I just don't understand how we spot this. Like, how do we know that this is out of bounds? I'm confused. The table doesn't have a maximum size. Let's have a look here, see what it says about tables. Yeah, okay, so it can grow to any size. So why does this give out of bounds table access? Let's look at execution, I suppose. Modules, instantiation. I suppose element. Sorry, I'm a bit lost. I don't understand how we know that this is out of bounds. If the narrative is that tables can be as large as you like, and then this is referring to, I mean, obviously this -1 becomes a very large 32-bit number. But what's wrong with that? I mean, obviously the Ruby interpreter doesn't like it, but how am I supposed to detect this problem? Is it in validation somewhere? I32. Integers are not inherently signed or unsigned. Their interpretation is determined by individual operations. So that would all seem to suggest that it's okay to have this here. Oh dear. I'm a bit stuck on this. I'm not sure what to do. Like, obviously I'm going to need to do something. Because these negative numbers are really messing this up. but I don't understand why. Oh, is it just because tables have a current size? Is it that simple? That although they have a maximum size, they also have a current size. Is that just what I'm missing? That a table gets created. Let's see, tables. Let's look in here. Specifies the initial size of the table. Okay, right, all right. I'm sorry, this is very silly. I just wasn't thinking straight because I'm very tired. So every table has got a number of elements in it, right? And so let's just say like raise if offset plus element items is greater than table instance dot elements dot length. Hold on, what's element dot items dot length? Unhandled exception. So that's what I was hoping for. It throws an exception. So if I rescue that exception, oh, phew. Okay. All right. Well, I'm just gonna add that in. I know this is a bit naughty. I mean, it needs to be part of this commit, right? Otherwise, this commit has broken. Well, it needs to go earlier than this commit, basically. Okay, so let's just check that this doesn't break anything. So I think it was probably the... Was it the out of memory killer that was killing it before, or was it something else? I don't know. I guess it probably was. I'm not sure why it didn't just sit there forever last time, but I'm assuming it's because it ran out of memory. So this is going to be check that, and don't try to initialize a table beyond its current length, basically. This is important because lm.wast tries to use offsets like -1, which turn into very large 32-bit numbers. And MRI completely freaks out if we try to write to that index in the table array. It's correct to just raise an exception here because that's exactly what the assert trap in lm.wast is expecting to happen. Okay. So now everything will hopefully be fine. Wow. Okay. Well, that was an unexpected bummer. Yeah, I don't know why didn't I spot that at the time? I think it's just because I wasn't paying very much attention to the, well, I just wasn't paying very much attention. I wasn't really watching the test output and I didn't notice that it had just got completely frozen. How annoying. It feels like that was, well, it was a waste of time is what it was. And the main thing that wasted time was me just not understanding that a table has a current size. It's not necessarily the maximum size of the table that matters. It's the current size of the table that matters during module instantiation. Okay, so hopefully now we can get back to start functions. But I've sort of completely lost that train of thought on account of what just happened. So I'm just starting to do this while I'm waiting for those tests to run. So what I'm going to do is when we're parsing these text fields, rather than just ignoring the start, I'm going to say start equals parse start. And I'm going to put start here. And what does parse text fields get passed to? Oh, the module constructor. So module is going to need a start. And I don't think we're going to need a sort of, okay, that looks good. I'm working in these files that are, I'm halfway through a flipping rebase. Okay. Okay, fortunately, that was fine, that merged fine. I am losing my grip on reality here, but it's so tantalizing that I'm going to try to keep going. Okay, so we're going to put start on module. We return it from parse text fields. I think that means I also need to return it from parse binary fields. So let's just do it down here. Parse start. What's a nice simple thing that it's like? Like maybe something like this. Okay, so we're already inside the list, so we're going to read start. And then I think start has to have a function function ID, right? Like it's not optional. That would be bonkers. Right, we just have to read a function ID. So we do that. Oh, actually, maybe it's this. Parse index context dot functions. Maybe that's just it. And this is an index, so it can be, yeah, either an ID or a numeric index, which is what we want here. So I think maybe that's it. Well, let's try the... Okay, so it's still parsing it successfully. But now in the interpreter, in instantiate module, we need to say something like if mod dot start unhandled exception, right? Something like this. Really cobbling this together. Something like that. I guess we don't need to say current module here. We already have the functions. And I guess I can just inline this. Hey! Yes. That was surprisingly easy to support. Nice. I'm assuming that hasn't broken anything. So let's add that stuff basically. Add start function to module AST node during parsing. Well, start function index. And then this is invoke start function if present, well, during module instantiation if present. And then start. Add start.wast to parsing tests. I'm going to start these again, and I'm going to let them run through once successfully just to reassure myself that nothing else weird has gone wrong, but I am going to treat myself to preemptively clicking this. Okay. Wow, this has been a bit of a slog so far. So, but look, only 3 tests remain, and hopefully these are relatively simple because I've already implemented memory fill.
I'm not sure I understand.
Oh, Siri, now's not the time. So let's see, table fill, table grow, table size. So those are all table instructions. Let me at least think about what they're supposed to do. Fill, grow, size. Oh, let's think about fill first. Table.fill instruction sets all entries in a range to a given value. Okay, that sounds like something we can do. Table size instruction returns the current size of a table. The table grow instruction grows table by a given delta and returns the previous size, or -1 if not enough space can be allocated. Okay. It also takes an initialization value, right? Okay, so okay. From the stack, one assumes. So yeah, this doesn't explain what, you know, what the arguments to these things are, but I think that's enough for me to guess what's supposed to happen. So again, while the tests are running, let's just have a look at table fill. Sets all entries in a given range to a given value. So statically, it only takes the table ID. Oh no. Why is linking stopped parsing? No, don't do this to me. Excuse me. Hold on. This never worked, did it? This never worked. What did I get confused about here? This didn't work at the time. Although I have done a rebase. Oh no. Undefined method types for nil. So where is this? I really am losing my grip now. Okay, well, never mind about filling tables. We're back here again. So this was the original problem that I was trying to solve. So, I mean, I'm going to watch the video back later and try and understand what's gone wrong here. But I think that perhaps, I mean, was I just running it against a copy of the test that I'd modified rather than the real one? I mean, it definitely looks like that's what I was doing. So I think that was a mistake. So yeah, this was where I started, wasn't it? Tables. More tables. Yeah, I think I probably got confused. How can we be back here again? Although this does look rather like a different problem. This is saying that the function doesn't have a module set is the problem. It's like, okay, well, let's so inside invoke function, invoking function, function inspect. Let's just pp that function. So the first function that's being invoked here does have a module, and this is a call in direct through the table. So it's going to be pulling the 0th thing from the 0th table. Table index 0. Yeah, okay. So this is all okay. It knows what module this is in. But then the call in direct is retrieving a function from a table that doesn't have a module. And it's the right function. It's the const 0 function. but somehow we haven't kept track of what module it was in to begin with. So how are we supposed to have done that? Oh, it's because module instantiation didn't succeed. This function never gets pointed at its module because module instantiation doesn't succeed. So maybe I can fix this by doing it earlier. Like, can I do it here? Well, that worked for that. Oh, okay. So I should have just done that. I think I should have just moved initialize functions. I should have just put it earlier. You know. So in this, sorry, I've become inarticulate again. What I want to do is change my mind here and initialize functions as early as possible. So there, we initialize it as early as possible. And here we say we initialize functions as early as possible in case module instantiation fails during initializations of globals. Oh dear. Globals, memory, or tables. This could potentially result in functions being stored in functions from this module being stored in tables, being stored in another module's imported tables. So it's important that those functions are set up correctly first. Okay. And now I just need to deal with the inevitable merge conflict. So now that goes there. Now what? What's happened? What? Invoke start function during module instantiation if present. What a mess. Okay, sorry, I don't know what I did there. That's the change that I want. Okay. Let's run these tests one more time and check that there's nothing else that's gone horrendously wrong. I'm not having good luck today. I don't understand how I overlooked that earlier. Other than just sort of fatigue, I think I just wasn't thinking straight, and I must have been operating on a copy of linking.wast rather than the real upstream one. I mean, I think in order to save a little bit of face and justify myself, I will say that I think some of these problems that I've been having on this stream are symptomatic of the fact that the tests take so long to run. I think if I could run them in 5 seconds, I would have spotted those problems as soon as they happen, but because they take ages to run, and I keep switching away and starting work on something else and then forgetting to come back and check the results, it's making me miss things that I would have noticed sooner. I'm leaning so heavily on these acceptance tests. Like, these are really all I have. I mean, obviously I have the language specification, but like, these are the only thing I have to tell me whether what I'm doing is right. And I'm so dependent on them, and yet it takes a really long time, or what feels like a really long time, to run through them all. Okay, we're getting there though. This is the last bit. So I'm not sure what the solution to that problem is, but I do maybe need a solution to that problem, because it's tripped me up more than once that I didn't spot this at the time. So yeah, it's a bit of a problem. Okay, let's just watch that finish. Okay, great. Phew. All right. So at least everything is working right now. Let's go back to my table.fill. So it looks like fill. What instructions do I already have that operate on tables? Table init, table get, table set, table copy. So I think table fill is going to be something like you give it a table index. Oh, that's all you give it, isn't it, statically? But then what it's doing is reading. So hold on. So there was something semi-useful here in the structure section. Oh, sets all entries in a range to a given value. Okay, that's not very helpful. So oh, I remember what I did before for the other table instructions was that I just looked at the operational semantics and tried to understand it. So let's see, get, set, size, grow, fill. Let's look at this. So I think what I learned is that usually the last one is the happy path. So this is I guess this is the stack. So we've got we've got some value for filling, and we've got some value n here that's going to be decremented as part of the operational semantics here. Oh, right. So this is turning it into table set. I mean, I had memory fill, didn't I? So let's maybe think about that. So table set works like that. Table init, destination source length. Like that's also kind of similar. So this does look quite a lot like offset value length, doesn't it? This is like memory fill, basically. So we pop offset value length times do. Like the table is current module table slice index, and then we say this is like table dot elements offset equals value, but it's like offset plus index. That might be it. Yeah, and then this is just the recursive definition of that function, but okay, so mean, obviously this isn't going to be enough because I can't parse it yet. So this is going to be complaining about table.fill. So I'm going to do this. Read index. Oh. I'm not sure I know what the index is here. Oh yeah, that is, I think that is just the I'm confused about indexes here. Is it like parse index context.tables, presumably? Like index equals if peak in index regex, then this, else 0, I think. All table indices might be omitted, but from table instructions defaulting to 0. Yeah, look, same, exactly the same thing here. Okay, so I think maybe that's it. So hold on, can I roll that in with the other? Yeah, I can. Oh dear. That's very silly. I'm sorry. Okay, so. All right. Yeah, this is it. Support parsing the table.fill instruction. right, so that should have been a lot easier than it was because I just forgot how it worked. And then this is implement the table.fill instruction. And then this gets table fill. Yeah, I mean, that definitely works, doesn't it? Table fill. Okay, table fill done. 2 remain. Table grow. Okay, what does that take? Okay, so parsing wise, that's the same as table fill. So table size is going to be the same as well, but let's do them one at a time. So table.grow, table grow. We need to say table.grow here. So this exception would have been about parsing table.grow, no matching pattern error. Now the interpreter should, oh, this needs table size to work. Okay, let's have a look. Does table size need table.grow? Yes. So basically we're going to have to do these two together, aren't we? Well, let's just do it. Okay, so now it's successfully parsed it, no matching pattern error, and presumably size is successfully parsed, but we can't execute it. Okay, so grow. Table grow and table size. Okay. So apparently table size is our first problem here. So what was the table size? Returns the current size of a table. All right. Stack.push table elements. Yeah, this is just a wrapper around an array, right? So it's just that. And table grow. So table grow by a given delta. Do we already have a grow? Memory grow. Memory size. So I'll put these the same way round, I think, as I did for memory. So I'll call this delta. Although actually, let's have a look. Table instructions. If I'm just looking to see if grow gives it a name. It's just n. Okay. And then this is returns the previous size. So we're going to need that. Previous size equals current module so this is table elements length. Oh, it also takes an initialization value. Val. Is that the right way around? No, it's the other way around. So memory grow doesn't do that, but table grow does. So you have a value, you have some delta. Maybe I'll just say delta times do table.elements push value. And then stack dot push previous size. That seems to be roughly what's required. Oh dear. This again. Okay, so table size, I guess, is just not right. Size T2. Expected 0 got 3. Size of table 2 should be 0. Okay, yeah, so this is just calling table grow and table size. Oh, so I guess it's the maximum size is the issue. So okay, so the first two pass in that they return the right values, but it shouldn't have grown it that big. Okay, so we do know the minimum size and the maximum size. But we lose that information. Yeah, memory's got a maximum size, and we need to do that for tables as well. So hopefully we've got the maximum size on the table. We've used the minimum size to like, well, there's an abbreviation here, but maximum size I think will be nil if there isn't one. But if there is one, then we need to respect it. So that hasn't broken anything. What are the semantics here? If it's or -1 if not enough space can be allocated. So growing tables. So if limits prime is not valid. Right, okay. So I think oh right, so we're actually not this throws away, there's a drop up here, so this throws away the result. So we're not even checking the result value here, but this just has to fail. So let's say if previous size, well, let's say if table maximum size is nil, or previous size plus delta is less than or equal to table maximum size, then we actually grow it. Else, we don't actually grow it. Oh yeah, sorry. Of course, I mean the unsigned representation of -1. Okay. Nice. So cool. So table size is passing. So there's something I can add here, which is so this is so this is like remember table maximum size from AST at runtime, so that we can do bounds checking for table.grow. So table size is okay, but table grow is still wonky. Maybe I could add table size now, like implement the table grow and table size instructions. And now I can put table size here. Table size to parsing tests. Tantalizingly close, but table grow is a problem. So is that first chunk okay? Maybe the thing to do here is to comment them out from the bottom and see how far down we can go. Okay. Okay. Okay, assert trap, out of bounds table access. Okay, well this, I mean, this looks very suspicious, doesn't it? Reject growing to size outside I32 value range. Okay, right. So right, okay, so this is saying that grow, I mean this is weird anyway, because like that's not even an I32, but I suppose we're sort of parsing this. I'm actually not sure what I do here. So the table itself doesn't have a maximum size. But grow here if length is larger than or equal to 2 to the power of 32, then fail. Okay, so I think we can basically ignore all of this. It's just that one that's problematic. So let's see. Growing table by delta. So how large is this number? Sorry. That's a little bit concerning because that is 32-bit. And it's not larger than 2 to the power of 32, so how am I gonna notice that this is bad? I mean, Oh, I've misunderstood. It's okay. It's when you add these two together. Right. So this plus, oh, so OX10 plus this. Right. Right. If it's larger than or equal to. So the range check here has to be so let's do next size here. So next size has to be less than 2 to the power of 32 and that. I mean, hopefully that will make the test pass. Okay, yeah, so that fixes it. I'm just wondering if there's a better way of writing that condition. Could I just say if previous size plus delta is less than or equal to maximum size, and then here we just say maximum size equals table maximum size nil, then it's 2 to the 32 minus 1, or it's table maximum size. That achieves the same thing. Check that final table size is less than check that table size will be less than 2 to the power of 32 after table.grow. Is there a better way to I realize I'm basically done, but I just wanted to check to see, is there a nice way to make an array? Yeah. How do I add stuff to an array? So if my array is 1, 2, 3, and then I concat array new 5, 1, 2, 3, it will stick them onto the end of it. So I think that's what I should be doing here, not delta times. I should be doing table elements concat array.new delta value. Let's say use array concat and array.new in table.grow implementation. And now table grow. Well, I am far too sleepy to celebrate, but oh, that was anticlimactic. Okay. So that's it. That's all of the tests. I'm running all of them. So that's it. That's where I wanted to get to. All the tests are done. Which is great. That was what I wanted. It was more of a slog than I was anticipating. But we got there. I mean, I'm just going to delete all of this now. So, oh my goodness. I don't think I can do anything else. Let me clean up some of these things that have already been done. I did those last time. Okay. So obviously I'm just waiting for this to confirm that everything's okay. But I mean, well, I'll talk about it a bit next time because I'm too sleepy to talk about it properly now. But obviously part of me is very happy to have got to the end of that list. So now everything here, we are executing the assert returns for all of these files. So we've implemented enough of WebAssembly that all of these work. So that's pretty cool. Here comes the traditional thing to do. I mean, it does feel like a bit of an anticlimax after such a long multi-month build up to this point, but this is great. Okay. Well, let's just see the test run. Yeah, I mean, obviously mistakes were made. I did screw up a few times during that. I think, my concentration was waning. I wasn't running the test regularly enough. I think I got overexcited when I got that. I'll watch the video back later, but I think what happens is that I got overexcited that after that that copy I've made of linking.wast had been failing for so long that when it started passing, I was like, great, it's done. Hooray, let's continue. And I think I failed to notice that that the real one wasn't running, possibly because of that lm.wast problem, that, it was causing the test suite to sort of hang at an earlier point, and so that was preventing me from noticing that there was a test failing there, and then it took me a while to notice that it was hanging, and so on and so on. So yeah, plenty of blame to go around, but I got through it, and now all of the assert returns in the code base are passing, and and also we had to get some of the assert trap stuff half working, so some of that sort of started to make inroads to that as well. Yeah, I think next time I'm gonna have to start. I'm not gonna immediately start on the vector instructions, but I think what I'm gonna do is start on the other. All of the skipped assertions is what needs to come next. Yes, it's gone green. Okay, that's great. Okay, well, I'm very tired. If I was less tired, I would be more excited about having reached 100%, but I just need to go to sleep now, and that was actually quite grueling because of the sheer number, the sort of the recursion depth of the rabbit hole that I ended up going down with some of that. But I'm extremely relieved to have got to the end of that. It's a big milestone for me and for the project, so that's exciting. And yeah, I'm happy I managed to get it done. I mean, is it before the weekends? It's 1:52 a.m. in London, so on Saturday morning, so not really, but still Friday East Coast time. So yeah, what I'm trying to say is I'm glad I got that far. And I made a big mess while I was doing it, and there needs to be lots of refactoring and tidying up done. Maybe that is the next thing to do, is to do another round of refactoring and tidying and stuff before cracking on to getting more of the assertions working, because I think now, having taken a horizontal slice through all of the pieces of functionality of WebAssembly, enough to get all of those test scripts passing with the assert return assertions, maybe this is a good time to take stock and do a bit of tidying up. But anyway, enough of that. I will say bye, and go and get some sleep and go and enjoy my weekend. As always, I'm super grateful to you for watching or reading or listening or whatever to this. Thanks for caring enough to pay attention for at least long enough to hear me say this, even if you haven't been here for the whole stream. So yeah, I'm extremely grateful. So thank you. Hooray! And I'll see you next time for whatever the next phase of this project is. But phase 0 complete. See you next time. Bye.